Welcome to the presentation on Tools for Mastering Mathematics. This is designed within the framework of my book called Tools for Mastering Mathematics, which I wrote with Nathan Josette back in 2014, around 2014. This book is available for free now if you reach out to me at Amos, the math guy, Amos at countingtocalculus.org, or you can visit my website. So we are going to help students go from basic arithmetic all the way to the beginning of Algebra 1, around the beginning of Algebra 1. The idea of this particular video is to guide students through all the concepts, again, the elementary school math. Imagine if you could learn everything elementary school math in one video. Well, we're going to do it in a couple of videos, but this is one of the videos we're going to use. So this is the beginning. Welcome. My name is Amos Tarfa. I'm a medical physicist and math and science curriculum writer, and I look forward to sharing some slides with you and some pictures that I was able to generate to help make the point of what we're trying to learn. So our philosophy of mathematics is simple. Math is more than numbers. It's a tool for understanding our world. It's beautiful, and we want everyone to get to calculus as soon as possible. We want to focus on mastery over speed. We want to reduce duplication. We want to connect concepts, and we want to inspire learning. We want students to love learning. We don't just want them to be good at math. We want them to love it. So, what is mathematics? In the book, I start out by talking about how mathematics is like a sport with rules you master through practice. It's like building a house, getting a strong foundation, and then layers. It's like a tool where you create and solve problems. It's like an art. We can be creative within principles, within certain domains. There's different ways to solve certain types of problems, and that's okay. And we just need to make sure that the method we're using is logical, makes sense, and can be, is it true? Is it valid? Or, is there a proof? Or are we just coming up with stuff that works in one case but not another? Math is like a language. It describes patterns universally. Math is something anyone, anywhere can understand. Like, we speak the same language of mathematics globally. That's why we've made this program. And one of the reasons is because we want all elementary school students around the world to master mathematics like never before. Every one of them to have a solid foundation to then move on into algebra and whatever else might come. We're going to dive into the concepts themselves, but I'm just giving you a quick background. So, what is mathematics? Here's Leonard Euler's perspective. This is a generated image that I thought was very interesting. And it just says that mathematics is the doctrine and calculation of numbers. It's the science of quantity, a universal method for dealing with all possible calculations regarding quantity. Abstract, generalized approach to structure would be more algebra. And then arithmetic focuses on specific concrete numbers. This is from Elements of Algebra, a foundational text that I've referred students to, and it's included in our online course. The journey begins, but before we dive into the journey, how did we get here, right? What is the history of mathematics? And so if Newton was quoting someone when he says, "If I have seen further than others, it is by standing upon the shoulders of giants." So, history of mathematics, I've broken it down into 4 categories: ancient history, Middle Ages, early modern history, and modern history. I want students to be able to understand mathematics within those 4 periods of time. You can break it in different ways if you want, but can students tell the history of math, the 4,000-year history of math, going back to, let's say, Abraham, for example? Can we go back to about 2024 BC and tell a story about the Babylonians or the Egyptians and the different civilizations that had an impact on mathematics? I have a whole presentation on this. You can reach out to my email if you want me to send it to you. But I just wanted to say that this is part of what's embedded in our training. So there's 4,000 years of math history from Abraham to the age of AI, quantum computing, and the space era. I'm not going to Mars, by the way, but I just wanted to say that math is what's going to drive that as well. So this is just a picture showing you the kind of the flow, ancient history, Middle Ages, early modern history. Why did I choose these timelines? Well, we start from ancient history all the way till about the fall of Rome. Some people use that date, about 476 AD. And then I go for 1,000 years from that time to the printing press. The Middle Ages is what I wrap it up to. And then the early modern history would be the printing press to the birth of America, or I'm recording from Texas in the US. And I was trying to map out a timeline that can help me make sense of some key events in history. So that would be 1476 to 1776, and the numbers are just nice and round. And then from 1776 to 2026. So who are some people in mathematics we encounter? People like Pythagoras, people like Euclid, Archimedes, Fibonacci, and Descartes. Each of these people played a key role. More people did, of course, a lot more. But again, for a full list of the math history, reach out to Amos at countingtocalculus.org. Mathematics is, of course, also relevant in the real world. Medicine, finance, technology, art and music, sports, and engineering all depend on mathematics. Almost everything you do every day has some level of math involved. So what are some keys to mathematical success? I'm recommending about 45 minutes a day of practice every day, year round, except short breaks here and there. But year round, we learn math. There's no reason to take a summer off. This is not the farming era where kids were farming full time. We need to recognize they have time, and the more we put them in a regular practice mode, it helps, because then they don't have as much time wasted on other things, which we won't get into in this video. We need to show our work, catch errors, understand thinking. We need to ask questions. There are no stupid questions. We need to learn from mistakes. Errors are opportunities. We need to master basics first, understand multiple methods, teach others for deepening our understanding, and stay curious. Discovering patterns and beauty is something I've always loved doing. So mathematics is a journey. Everyone can learn math with effort. Mistakes are valuable learning opportunities. Speed doesn't always equal understanding, and your ability grows with each challenge. Don't give up. Get a group of friends. Keep learning, keep growing. Let's get started. So we're going to do elementary right now, counting, place value operations. We'll dive into fractions, exponents, variables, and then algebra 1 concepts, algebra 2 concepts, and then beyond. Those will be covered in a different series, but this is getting us started with the pre-algebra. Okay, let's begin our journey. So in this section, we'll focus on the fundamentals of mathematics. The first thing to discuss is place value. Every digit in a number has a place value. In the number 4, 5, 6, 7, 4 is in the thousands place, so we have 4,000. 5 is in the hundreds place, 6 is in the tens place, and 7 is in the ones place. So it's important to know the place values. We can write the number 3, 4, 5, 6. We could show the place value of 3,000s, 400s, 5 tens, and 6 ones. We have the similar, we can do it in a different way below, the expanded notation there, 7,000 plus 800 plus 90, and then plus 0, because there's nothing in the ones place. The history of 0 is a fascinating story you should look up as well. Very interesting that we didn't always have 0 used the way we do today. And then we can write 5,000 plus 200 plus 30 plus 8 in standard form, and that's 5,238. Each place is 10 times bigger than the place to its right. So why don't you try this out? Place value to 10,000. Go ahead and pause or stop at this point. Try out these problems, and then we can discuss in the next video. So we've started our counting journey. We've explained why we're doing it, and this is the place value section. We will dive into more examples and concepts in the next video. Thank you so much for watching. I'm going to leave you with this slide, which just shows you more details with the place value. But yeah, I look forward to sharing more with you as you seek to become very good in mathematics and help others as well. My name is Amos Tarfa. Feel free to like, share, and subscribe. We'll be talking more about mathematics on this channel. Have a blessed day.